Hello everybody, today we are going to discuss the using of the Statistica program for medical purposes as a medical statistics. Firstly, before we start diving into the program, we have to understand the statistics. What is the statistics? We use statistics to confirm or reject a hypothesis that you suggest, and you can also use it to confirm or reject the null hypothesis, the primary idea that the people believe in. So, for using the Statistica, you have to download the program Statistica. You can buy it. It exists on Google. You can write Statistica and download it. When you download the Statistica, you are ready to follow my steps. We open the Statistica, but before you start working with your data, you have to insert them into an Excel file, because in the 10th version of the Statistica, you cannot edit or you cannot insert or open the Excel program inside. But the 13th version of the Statistica, it is an amazing version when you can open the Excel program inside the Statistica, so you can use two programs at the same time. You can use functions of two programs at the same time. So it will be more comfortable if you buy the 13th version of the Statistica program. And something interesting on the statistical program, that it understands the text, which is that's why I prefer it on the SPSS program, because in the SPSS program you need to change the text into encode them into numbers. For example, yes or no. Yes, you put 1, and no, you put 0. So it will be more easy to use this program, and I think it is more comfortable to use. For me, it is more comfortable. So after you correctly insert the data into the Excel file, you are ready to open it. Go to the home and open the file. It is not difficult. You select the Excel file and you open it. That's it. After you open the Excel file, it will shows for you. It shows for you in the Statistica program. There will be, if you have in the Excel file only one sheet, it will shows for you here only one, not like me. Here there are six, but only one. So if there are more than one, you need to select which sheet you want to use for the statistical analysis. I will use this one, the 1, 2, 3, 4, the fourth sheet. You right click and use as an active input. Yes, we select it and use as an active input. Now we selected it. There is a red square on it, so we select it. Now we need to understand some things about the statistics. In the statistics, there is two parts, two sections. These are the parametrical normal distribution and non-parametrical not normal distribution. For the today class episode, we will speak about the normal and parametrical distribution. It is a little bit longer, and it requires longer lesson for it. So in the parametrical data, the primary data, the normal distribution, we use the basic statistics which are suitable for us, and the ANOVA tests. Then the multiple regression, I rarely use it. I use it only when I want to show the direction of the correlation, if it is direct correlation or it is an opposite correlation, it is in the same way or it is in the opposite way. So I use the multiple regression only in this case. The first step, when you open your sheet, you need to check the distribution. The distribution, you click on it, you select normal distribution and OK. For the variables, you select the numbers where there is numbers. You see here in the sorry, you see here there is numbers in the total hospitalization date. You see numbers, how many days the patients stayed in the hospital. So you see 12, 10 days, 16 days. Hospitalization date, you cannot select it because it is not correctly inserted. So we select where the data inserted correctly. For example, total hospitalization dates. And you can select some data from here also, but I prefer to use this one. If it is not, for example, present, you can select the age, maybe anything where there is numbers. If there is no numbers at all, we need to think about it logically. The number of the participant, is it more than 30 or less? If the number of the participant is more than 30, it is most likely that the sample has a normal distribution with parametrical test. We use the parametrical analytical test. So in my case, there is 101 participant, 101 patients. So the sample, I think it's most likely will be a normal distribution. Let us check it, and we see using the age, for example, and we check for the distribution. So after the distribution results will show for us, we will continue to the basic statistics. In case of the basic statistics, number of the valid cases. So it is opening a Word. Here it will opens into a Word program, so it will be more easy for you to edit and copy paste and modify the charts because they will show into Word program. Not only the Statistica, but the Word program too will open here. Okay, we are waiting for you when you will open. In the results, the shape of the chart must be only one peak. If there will be more than one peak, the results will be considered not normal distribution. Sorry, I selected summary. I must select the chart, not summary, but the chart. Unfortunately, I'm incorrectly selected the. I must select the plot. Yes. So the chart shows me only one peak and it is normal distribution. If there is multiple peaks, more than one, for example one here, one beside it, so it will be not normal distribution and we cannot use the parametrical test. Now we return to the stat sheet, the statistical, the primary data sheet. We go to the basic statistics. So first step, you check distribution by selecting the distribution and select the variable where there is number you selected, then select plot. That's it. If you see the chart shape is one peak, there is no multiple peaks, so it is normal distribution. Okay, we go ahead, go to the next. Go to the basic statistical test. Go to the descriptive statistics. The descriptive statistics, they are important for us They shows for us general overview of the sample, the mean of the of some values, and it is usually important where there is numbers because it shows for us not the frequency of the recurrence or the occurrence of some facts or something, but they shows for us the means of some numbers. If there is numbers, it will show for us the mean of these numbers. So we select variables, select all variables, and click OK. This is summary statistic. Now we can see that the mean value or the val number of the total hospitalization days is 100. The mean total hospitalization days is 14 days, minimum 5, maximum 30, and standard error. I also suggest for you to add the add advanced and median. It will be more good for you when you describe the results in the your article or your research. So how you can describe these results? You say that the mean total hospitalization days is 14 and the minimum value it will be between two brackets, the mean, the minimum, the maximum, mean, minimum, maximum. Or it can be an opposite, the mean, maximum, and minimum. But I recommend use the mean, minimum, and maximum. Or another way you can describe median and standard error as you like. You describe the result as you like. You have two ways, either mean, minimum, maximum, or median and the standard error. What is the difference between mean and median? The mean is the sum up of the for example total session days. You sum up all the total session days and divide them on the number of the total session days. For example, there's 101 patients. You sum up all the hospitalization dates, for example 10, 13, 14. You sum up all them and divide them on 101. The mean it is not so. The mean it is you arrange or order all the values, all the numbers from the smallest to the biggest, or oppositely from the biggest to the smallest, and you take the middle value. If there is no middle value, for example you have two values, not one, you sum up the two values and divide them on 2. You will get the median. So you get the idea. You either use mean, minimum, maximum, median, standard error. The same for this descriptive statistics. It is important for us. For example, we can see that there is uh, uh, important the age. The mean age is 64. The median is 66. Minimum it is 16. The maximum it is 100. You see, this is the big gap between the minimum and maximum age. So maybe it will be interesting for us to divide this sample by age from the, for example, from 60 to 40 years old, and from 41 up to 100 years old, and we can check the differences between the two groups according to their age. So this is the main function of descriptive statistic, in addition to the primary description of the sample, the mean values of the sample. Next, we will go ahead and continue with the correlation matrix. The correlation, it shows us if there is any association between two facts or two factors. Yes, we usually select two lists because one list it is usually mm, not useful for us. We have always almost two groups and we want to compare them. So two variables, for example, age, well, age with the let's select all of them. So it doesn't matter, select all of them and let us see the summary correlation. Okay, what we see, the red marked results, these are statistically significant. We do not need to miss them. We always must describe the results in the red. You see they are somehow repeated, yes, because they are crosswise, these results, so they were repeated. The results, for example, the correlation between age, this one, between age and the white blood cells. The second analysis, yes, the second analysis, not the first, but the second one. So there is a correlation in 0.9, in zero point 0.9, the value of the correlation, and the correlation it is 0.05. The p is 0.05, so in 95% these results are significant and we can use them as a basis for the future studies. And so on in the other results. So if each results marked in red, it must be described, and you can see, you click on it, it will shows for you the correlation between what two factors. You click on this number, it will shows you or highlight for you the hematocrit first analysis and hemoglobin first analysis. There is a correlation, so we can suggest that an association is exist or exists between the hemoglobin one and or the hemoglobin in the first analysis and in the hematocrit in the first analysis. We go ahead, go further to the next test. It is the t-test, independent by group. The t-test is the most important test that we use in the normal distribution, the parametrical analysis. The independent, it means that there is two groups, they are independent of each other, and by groups it means that we divide the sample, for example, into two groups, so it's called by groups. For example, by gender, male, female, only two choices, male, female, yes, no, agree, not agree, and maybe a living place in the city, village. So only two choices, the dividing group. So they are independent and they are divided by groups. So you understand these are text. Usually these are text. I mean these are not numbers. The dividing groups, for example, gender. It is male, female. They are, you write them as a text. Yes. So these are text. Female, male, yes. So you do not write them as a 0, 1, or you encode them. You do not need to encode them. It is text, and the dividing group is usually text, not a number. You can encode them, yes, but they will be not direct results. You need to explain these results, because if you write 0, 1, the program will understand it as numbers, not as grouping variables. So we need to explain them that 0 it means, for example, no, and 1 it means yes, agree, not agree, city, village, and so on. And so we continue with the t-test independent. Let me show you an example. So we select variable, the dependent variable and the grouping variable. We can select all the list and the dependent variable is only one. So the grouping variable is only one, the dependent variables there are many. So you can select the whole list. It's up to you what you want to compare. So I prefer to compare all the list and check if there is any maybe dependent values on some of the grouping variables. So let us select the living place. So it will automatically shows for you the code of a grouping. So group 1 it is city, group 2 it is village. So it is understandable for you that you cannot select a group with multiple more than two choices. For example, village, city and sub-village or sub-city between them. So it is impossible to select more than two. Only two choices there is in the t-test. So we can see that there is a strong difference in the direct bilirubin 1 value between the city patients who live in the city and patients who live in the village, and the p-value it is 0.03, so it is 97% there is statistically difference between the patients who lives in the city and who lives in the village. The levels of direct bilirubin they are statistically different. So each time you see results marked in red, it means these are statistically significant and you must to describe them. We continue next, we take another example. For example, by using the ringer plus the ringer slide and the plot filling. So it will automatically analyze and show for you the grouping yes and no. You hit on summary and you see the result that there is a difference between the RPC values of the patients who got the ringer and who didn't got it, the p-value and the others are the same. Continue to the next test. It is the t-test independent by variables. By variables, it means it is numbers, not a text. For example, let me show you. Here we have in this column we have numbers. You see 12, 10, 16. The total session days it is numbers. But here in case of the sex, the gender, there is male and female, so it is a text. Yes, the program understands it as a text, so we can divide this sample by groups, which is male female, and it is a grouping t test by grouping, but here it is t test by variables, here by variables, and so on with the other numbers. Here it is all by variables. Yes, so when we want to compare variables with numbers, we use the t-test independent or dependent by variables. Yes, so we for example compare age with, we'll take the hemoglobin 1 and the hemoglobin 2 and compare them. I have to mention that comparing the hemoglobin 1 and hemoglobin 2 it is not totally correct, because these variables they are dependent results, they are not independent, these are dependent, these are the same patients. So it shows for us that there is a difference between the mean values of the hemoglobin 1 in the first group and the hemoglobin 2. So these are cannot be divided into groups. and the p-value it is on 100%, it is statistically difference. So in this case we are showing that there is statistically significant difference between the hemoglobin 1 and the hemoglobin 2. Yes, the hemoglobin value 1 and the hemoglobin value 2, the mean value. We continue next to the next test. It is the t-test dependent. What does mean dependent? Dependent, it means, for example, we have got 3 or 4 patients, for example. It is a small sample, yes. We have got 3 or 4 patients. We made for them analysis CPC for them today. We wanted to follow up them for maybe 1 month. So we done 1st of September test CPC, and on 30th of September we made second test. We repeated the test. So in this case, these are the same patients, the same person done the test 2 times. So these results are dependent. This rule also can use in case of in vitro studies using animal models, for example, using mice, rats, monkeys, and so on. So when we, for example, give drug for a mice to check the erythropoietin level, if I mean the erythrocyte level, by inducing erythropoiesis. Yes, so for example, we give them a drug that induces erythropoiesis. Before giving the drug, we check the erythrocyte level, the red blood cells, and for example, after 3 6 months, we repeat the test and check if there is any change in the levels of the erythrocytes. So this is the same idea. It is the same mice or the same animal, but we repeated on it the same test, so it is independent results. We need to use the t-test for dependent sample, but we have to remember that t-test is only for normal distribution and parametrical primary data. And I said that the parametrical data, the sample size must be more than 30 participants. So let us see an example. Dependent, we have here the hemoglobin. The hemoglobin, we repeated the test 2 times, white blood cell repeated 2 times, and so on. So you take the first with the second, the first with the second, or opposite, the second with the first, it doesn't matter, right? And so on for the whole results where there is 1 and 2, yes? So let us take these two examples and see the summary. We see that there is a statistically significant difference between, or dependence between the hemoglobin 1 and hemoglobin 2. Yes, so these are dependent on each other, and these results are statistically significant on 100%. The same for the white blood cells, they are significant on 100%, and the mean values of the hemoglobin and the white blood cell, they are significantly different. So when we describe this result in our paper, we use the mean value. For example, we say that the mean hemoglobin value in the first analysis it is 123, whereas in the second analysis it is 46. And we write a comma and say that it is statistically significant, comma, t-value, comma, p-value. So in this way we describe the results of our data. Next we continue, go ahead. Go to the frequency table. The frequency table is usually used in describing the materials and methods. I prefer to use it in the materials and methods